Hi, welcome to this video. So let us now have your kinematic equations. But let us assume that all these equations, kinematic equations here, has acceleration. Has a constant acceleration. So we have only three main kinematic equations. We say that A is equal to your derivative of B with respect to time. That is we review. Saan na ba yun? Okay, we have dv over dt. Then what else do we have? We have the kinematic equation for your velocity, which is velocity is ds over dt, isn't it? And then lastly, we say that lastly, to determine the third main kinematic equation, we need to determine the relationship between the acceleration and your position. Since for our first kinematic equation here, we can relate acceleration and velocity. Okay, on our second kinematic equation, we have the relationship between the velocity and your position, but we don't have the relationship between acceleration and your position. That's why we need to come up with the third kinematic equation so that we can easily relate those three: acceleration and velocity, acceleration and position, velocity and acceleration, velocity and position. So what we have here is acceleration and velocity, velocity and position, but we don't have the relationship between acceleration and position. That's why we can let us now add some third equation here by getting by tweaking some formulas here. For example, based from here equation here, we can get the value of dt, wherein dt is equal to, if you do the algebra, do that, dt is equal to dv over a. Alright, and then from this we can now also get the value of dt, which is equal to ds over v. Okay, to the algebra, and then from that you can now relate both dt. So dt is equal to dt. Since they are both equal, you can now substitute the value of this dt, which is dv over ez, is equal to ds over v. So the first dt here and the second dt there, and substitute the values. You can now arrive with this formula. And then let's do some algebra. The cross multiplication, we have v dv is equal to a ds. Okay, so from here you can see that v dv is equal to a ds. So we can add this third main equation of our kinematics. Based from here, we have v dv is equal to a ds. So from here we can now relate the acceleration and what do you call this, acceleration and position, as well as its velocity. Okay, so this main three kinematic equation here is very useful, and you only need to memorize these three. A is equal to dv over dt, v is equal to ds over dt, and v dv is equal to a ds. If you memorize these only three equations, then you can now solve all of the kinematic problems. Okay, all you need to do is to remember these three main equations here. So based from these three equations, it can be integrated. So when we integrate those three equations, we can obtain formulas that can relate v, s, and t, function of t. Okay. So let us integrate those values to obtain the relationship or equations, kinematic equations that can relate these three here, including the acceleration. Okay. So that is all for this video. I am running out of battery, so let me see you on our next video.